Hello, my name is Kellen, and today we will be taking a look at solving a set of non-homogeneous differential equations using the method of undetermined coefficients. So, a couple things before we dive in is what does non-homogeneous mean? Well, if you're doing sets of differential equations, I'm sure you kind of have an idea, but in the term of sets of differential equations, this right here, if we have some tacked on piece after our vector of unknowns and their constants, this is our non-homogeneous piece. So we could technically find a solution just equal to this. 6, 1, 4, 3 multiplied by our vector x, right? And then if plus 0 here, that means that that's a homogeneous set, where this here would actually be a non-homogeneous set. And in fact, we will be using this here. This is basically how we find our homogeneous term. And then our solution is simply just that x, where x is a vector of solutions, is going to equal x of h plus x of p, where p is our particular solution, and that's where the undetermined coefficients portion kind of comes into play. Okay, so I'm assuming that since you are doing non-homogeneous, you've already solved quite a few homogeneous. But just in case you need a refresher, we're going to go ahead and do it for this problem. We're going to find the homogeneous term here. So I like to kind of do differential equations in steps because it is very step-oriented and step-heavy. If you kind of follow the same procedures over and over again, it really can only help you in this course. So step 1, we need to find x sub h. Okay, well, we do that by finding our eigenvectors and our eigenvalues, and we can use the solution that x sub h is going to equal, this is assuming that we have only 2 eigenvalues, and this could continue on as many as you want. As a matter of fact, I'll just write out the equation to be such. So C1 times x sub 1, which is our eigenvector corresponding to our first eigenvalue. Okay, plus C sub 2, x sub 2, e to the lambda 2t, plus C sub n, x sub n, e to the lambda n t. Okay, and then remember that our x's, x1, x2, x sub n, those are simply just our eigenvectors, where lambda 1, lambda 2, all the way up to lambda sub n are just our eigenvalues. So, 1a, find the eigenvalues. And then we do that just by taking our non-homogeneous coefficients here. So 6, 1, 4, 3. And then we subtract lambda off from the diagonals. Okay, so we would do 6 minus lambda, and actually we take the determinant of this. So it'd be 6 minus lambda, 1, 4, 3 minus lambda. And then if you remember determinants, it was just these two multiplied by each other minus these two multiplied by each other. So that's equal to 6 minus lambda multiplied by 3 minus lambda minus 4. Well, that just equals, let's go ahead and FOIL it out, and we'll get, it's going to equal 6 times 3, which is 18, minus 6 lambda, minus 3 lambda, plus lambda squared, minus 4. Let's go ahead and simplify that up a little bit. So I'm going to go ahead and put them in descending order by powers. So we'll have lambda squared. Then we have negative 6 minus 3 lambda, which is going to be negative 9 lambda. And then we have 18 minus 4, which is simply just 14. It's going to be plus 14. Okay. And then that equals 0. And then we need to factor, use the quadratic formula, whichever you want to use. I'm simply just going to factor, and I'll kind of show my steps here. So we take 14, well, we break it down, and then so 1 times 14, 2 times 7, oh, that looks like that's going to work, but we're going to need a negative 7, and a negative 2 as well. And then if we just do that, we get lambda minus 7 multiplied by lambda minus 2. And then if you FOIL that out to check your work, you will find that it's going to equal the exact same thing as this. Still equal to 0. So we'll get that lambda 1 equals 7, and lambda 2 equals 2. Okay. So there's 3 steps to this, I believe. So then we do 2a. Okay. We substitute lambda 1 to get x1, where x1 is simply just our eigenvector corresponding to our lambda 1 value of 7, of our eigenvalue of 7. Okay. And then we do that by taking 6 minus lambda, 1, 4, 3 minus lambda, and then we have x1, x2 equals our 0 vector. I think probably like that. Okay, and then we plug in. Well, we're doing lambda 1 here, so you can even write lambda 1. So 6 minus lambda 1, well, that's just 6 minus 7, which is negative 1. 1 stays there, 4. Then we have 3 minus 7, which is negative 4. Okay, and then right off the bat, you'll see that there are only there's only one independent row. And that's very important because whenever we're finding our eigenvectors, it's usually best just to put it in row echelon form. If you're not familiar with row echelon form, I'm just going to write a side note here. There's reduced row echelon form, and there's row echelon form. Usually in these cases, it's easier just to put it in reduced echelon form which basically looks a little something like if we have value 1, value 2, that underneath value 1 needs to be a 0, and this can be a 0 or another value, but where value 3 can equal 0. And you'll find doing these problems that generally speaking, value 3 will equal 0, especially in this case here that we have. So we accomplish this by doing row operations. And then basically we just say that row 2 is going to, actually we'll do row 2 minus plus 4 times row 1. So row 2 doesn't change. It's going to be negative 1, 1. Okay, but row 2 does change. We said that we take row 2 and add it to 4 times row 1. Well, negative 1 times 4 is negative 4, and then we do 4 plus negative 4. That's going to be 0. Okay, we do the exact same thing with the second, to where we say that we have 1 times 4 is 4, then negative 4 plus 4 is 0. So that means that we have a rank equal to 1. So what that means is that we can take our x2, we can say we let x2, it can be equal to anything you want. It's a free variable. Whenever you have zeros on the bottom here, just let it be equal to anything you want. And I always like to choose 1 because 1's an easy number, and it works in your eigenvectors, so no problem there. Okay, and then we read off. Actually, let me move this around so I can kind of write it like this. Maybe it'll help visualize kind of the idea that we're working with here. So then we have, this doesn't change here, this x1 and x2 equal to 0. I simply just leave it off for notate. It's easier to notate. But you can always add it back on after you get your constants here into row echelon form. So then you just add it back on. And then also remember the 0 vector is simply just that. Okay, and then we said we're going to let x2 equal 1. And we should have 2 equations here. But we read off from the top, from left to right. So negative 1 times x1 plus 1 times x2 equals 0. But we said that x2 just equals 1. Okay, so now we get that negative 1 times x1 equals negative 1. Or x1 just equals 1. Okay, perfect. So now we can say that our first eigenvalue is simply just equal to x1, x2 like that. But we said x1 is going to equal 1, and then we let x2 equal 1, so that doesn't change. So we just found x1. Perfect. Now, step 3a, we substitute lambda 2 to get x2. Well, nothing changes here. So we had 6 minus lambda. Remember, lambda 2 is just 2. So 6 minus 2 is 4. This value here stays the same, which is 1. So does this value here. And then 3 minus 2 is 1. Okay. Okay. And then remember, we take this here, we put it into row echelon form. But right off the bat, we don't need to. Simply because we see that this row here is exactly the same as the first row. So we can already say that the rank is going to be equal to 2. So basically, we can rewrite this as that. Okay. Well, same thing. Now we let, and then I'm just going to go ahead and denote this the same. The coefficient matrix rank is equal to 1. So then we say let x2 equal 1, because we have a free variable here. So now I'm going to read across, and then we say 4 times x1 plus 1 times x2 equals 0. Well, we plug in 1 for x2. That's going to give me 4 times x1 plus 1 equals 0. Solve for x1. You'll get x1 is equal to negative 1/4. Great. That tells us now that x2 equals, same idea, x1, x2, which that's going to equal, well, x1 is simply negative 1/4, and x2 is, we let that equal to 1. And I put parentheses here just out of habit. You can write brackets as well, like I did previously. Great. So now we have everything that we need to assemble the homogeneous solution, to where the homogeneous solution is going to equal, and if we go back up here to our nice formula, we say that the homogeneous solution is going to equal C1 times our first eigenvector multiplied by E to the lambda 1t. Okay, so x sub h is going to equal C1 times x1, which is simply just 1, 1, multiplied by E to the lambda 1, which was 7, plus our second constant multiplied by our second eigenvector, multiply that by E to our second eigenvalue multiplied by t. So we just found the first thing that we need to actually get a solution to this set of non-homogeneous differential equations. Okay. Step 2. Is going to be apply method of the undetermined coefficients. So this, unfortunately, is kind of an art, and there's no perfect way to do this 9 times out of 10. The reason being is because this non-homogeneous term here, we want to make something look as identical to it as possible without a term, the same term, being inside of our homogeneous solution. And that can get kind of confusing sometimes. So it's best just to work on examples so that you know what works and what doesn't work. Okay, so I'm just going to go ahead and write our non-homogeneous term, which was 6t and negative 10t plus 4. Okay, so the rule of thumb is that whenever we have polynomials like this, we want to break it up into descending order of the powers of the polynomials. So basically, something like a and b multiplied by t plus c and d. Right? You see that here we all have powers to the 1. That's great. We have 1 there. And then now here we have basically just our constant terms here, which our constant terms are here. And then if we had squared terms, we'd stair step down from 2 to 1, back down to basically just our constant terms. So then what we can do is I like writing this because it helps me kind of remember. So we let x prime of p equals that. And then remember that our equation is actually that we're given all the way up here. We need to remember that we're basically given a set of differential equations that looks like this, where x prime of p equals our constant terms, which was 6, 1, 4, and 3, multiplied by x of p, plus, these are constants. These don't change. We're always going to leave the non-homogeneous term in our particular, whenever we're trying to form our particular solution. So, okay, and then we simply just need to plug in everything else. Well, oh, and I wrote this wrong. I'm sorry. It's not x prime of p. We let x of p, or a particular solution, be equal to something that looks like this. Okay. So now what we can say is we need to take this x of p and we need to find the derivative of it. So I'm just going to rewrite it here. Well, we said that we're going to let it be equal to something that hopefully looks like this. Okay. And then the derivative of this, well, if you remember how to take derivatives, this is our constant. That's just going to go to 0. And then this has the power of 1. So we're only just going to basically take the coefficients here, where x of p is going to equal a b, like that. Now it looks like a beta. Not exactly sure what that was. Oh my goodness. Okay. So now This is 1b. Oh my goodness. Oh, we don't need to write that. Anyways, so then our next thing that we need to do is we simply just plug in. Okay. So remember, we plug into our original equation here. And then we say x prime of p. Well, we said that simply just equals a b, this column vector here. And that's going to equal, well, this doesn't change, 6, 1, 4, 3 times x of p, but x of p equals a b t plus c d. Oh. And then these, that's all one term, plus our non-homogeneous term here. Okay. So now this can be kind of the trickiest part. But beforehand, I want to kind of I want to go back over this and make sure that we kind of really concrete the idea for this second step here of undetermined coefficients, because, well, that's what this video is entirely about. So, as I said, the hardest thing probably to distinguish in using the method of undetermined coefficients is, what do I want my particular solution to look like given this non-homogeneous term? And there's so many different ways that you can do it, and you know, your professor can even have many intricate ways. And hopefully, this is just kind of a brief introduction. Hopefully, we can maybe do a few more videos of some more complex non-homogeneous terms, you know, involving sine and cosines, like trigonometric identities, exponentials, and all these other sorts of issues. So, but given a simple polynomial, we basically just want to stair-step the highest degree down to its to a constant. So, and that's what we did here whenever we found x of p, right? And then we know that this is our solution. Our set of differential equations looks like this. And then in order to find our particular solution, we need to plug in x of p and x prime of p. Okay, once we plug this in, we can kind of get, in this case, since we basically only have two rows here, we'll have two equations. Okay, so how do we find this first equation? Well, we simply just read across from the top and multiply out and then add on the non-homogeneous. So A equals, we're going to have to multiply all this out here and then plus our non-homogeneous term. So let's kind of see how that works. So firstly, we'll see that A equals, okay, and then now we need to multiply out this here. And we do that by simply just writing we'll do 6 times A plus 1 times B, and that's going to be with our t's. And then we'll do plus 6 times C plus 1 times D. If you remember how to multiply out matrices, I would definitely go back and take a look at that. So yeah, let's just kind of keep chugging on forward here. So we'll get that A equals, well, we said it's going to equal 6 times A plus 1 times B, and that's our T term. And then we'll do plus 6 times C plus 1 times D. That's going to be plus 6T. There, our non-homogeneous term. Okay. And then we can definitely kind of simplify this. And I'm just going to go ahead and move this to the other side and perform the algebra necessary to do that. And what we'll basically end up getting is we'll get that 0 is going to equal 6AT plus BT plus 6C plus D. Remember, we're going to subtract this A over now, and then plus 6T. Great. Okay, and then I'm going to leave some room here because, like I said, I'm very systematic when I do these. And I know kind of the next step that I need to do. But let's find our second equation here, where we basically B is going to equal, well, now we multiply all this out, and it looks like that. Okay, so we'll do that B equals 4A plus 3B times T and then we'll add that to 4C plus 3D. And then let's not forget to tack on our non-homogeneous term. That's just going to be negative 10 minus 10t plus 4. Okay. And then if I do the same thing that we did on the other side, where we'll get 0 equals 4at. That is ugly. Let's try that again. 4at plus 3bt plus 4c plus 3d minus b minus 10t plus 4. Okay. And then always, 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 it doesn't matter if you have your non-homogeneous term has trig, if it has exponentials, whatever the case may be. We're going to break this up, each one of these equations up, into the t, and I'll explain what these mean here in a second once I write them out so that we have a good outline to work on. T in constant terms. All that means when I wrote this is that we're going to take, remember, we're kind of applying the original idea of undetermined coefficients and determining the coefficients for our constants and t's. So, like here, we have 6at, bt, and 6t. Those all are all terms that have t. And then why did I go ahead and make it 0? Well, because we have nothing now to, basically, all these are going to equal 0. So if I take my blue terms that I just highlighted, and I say 0 equals 6at plus bt plus 6t. Or we can factor out all of the t's. and get that 0 equals 6a plus b plus 6. Now, let's do it with our constant terms. So 6. Remember C, D, A, B, C, and D that we wrote in our kind of dummy solution here? These are constants. These are the coefficients that we are trying to determine. So now we can write that 0 is going to equal, well, 6c plus d minus a. And then if we go down to our second equation here, if we look at our t's, remember everything is going to equal to 0. That's why me personally, if I can, I like to make this everything equal to 0. It's just easier on the algebra, in my opinion. So where are our t's? Well, we have 4at, 3bt, and negative 10t. Then let's just go ahead and kind of underline our constants. We have 4c, 3d, negative b, and plus 4. So if we go ahead and write these out, we'll get that 0 is going to equal 4at plus 3bt minus 10t. And then we can factor out the t, and 0 divided by t is still 0. So we'll get the 0 is going to equal 4a plus 3b minus 10. Great. Now let's look at our constant terms. Well, we'll get 0 equals 4c plus 3d minus b plus 4. Okay, now all we need to do, we have, and you notice it worked out the way that we wanted it to, we have 4 unknowns and 4 equations. And that's nice. So if we take, let's see, suppose, what can we do here? We can take, yeah, let's start with, I'm trying to figure out whether I want to start with the t's or the constants, but I suppose we can just start with the t's. Doesn't matter. So yeah, let's just start with the t's, because why not? So I'm going to rewrite. We have 2 t equations, so 0 equals 6a plus b plus 6. We also have that 0 equals 4a plus 3b minus 10. And then if I go ahead and I multiply this one by 3, well, that's simply going to give me that 0 is going to equal 18a plus 3b plus 18. And then that second equation still stays the same. 4a plus 3b minus 10. And then now I go ahead and I subtract those. 0 minus 0 is 0. 18a minus 4a is 14a. 3b minus 3b is 0. And 18 minus negative 10 is going to be 28. So we'll get the 0 equals 14a plus 28, or that a equals negative 28 divided by 14, which also equals negative 2. Cool. Now we can go ahead and we can plug that back in to, really doesn't matter, whichever one you want. I suppose we can plug it back into this one here. So we'll say that 0 equals 4 times negative 2 plus 3b minus 10, or that 10 equals negative 8 plus 3b, or that 18 equals 3b. So we get that b equals 18 divided by 3, which is just 6. Okay, so now we found b, we found a. Now we need to find c and d. So let's go ahead on the next page here. I'm going to rewrite our other two constant terms, or other two equations here. We have 0 equals 6c plus d minus a, but remember a was just negative 2. Then our second one here is we have 0 equals 4c plus 3d minus b, that's going to be minus 6. So then we would have, let's kind of visualize it here, we would have minus 6 plus 4, which is negative 2. Okay. So, same idea. I think we just multiplied this one by 3 to where I would get 0 equals 18c plus 3d plus 6. Okay. Actually, just to make it simple, I'm going to go ahead and multiply this one by negative 3. So, I would get that 0 equals negative 18c minus 3d minus 6. And then the same is going to, the second one's going to stay the same, which is going to be 0 equals 4c plus 3d minus 2. Let's go ahead and add these. So we'll get that 0 equals negative 18 plus 4, which is going to be negative 14c. Negative 3d plus 3d is 0. And then negative 6 plus negative 2, it's going to be negative 8. Or we'll get that 8 is going to equal negative 14c, or that c is going to equal 8 divided by negative 14, which simply just equals, we'll simplify to negative 4 over 7. Okay, almost there. As you can see, undetermined coefficients is really time consuming. But let's keep chugging forward. So now we just need to plug in c into this other equation here, the second equation. So we'll get that 0 is going to equal 4 times c, but c was nothing but negative 4 divided by 7 plus 3d minus 2. I'm just going to go ahead and do 2 is going to equal negative 16. all divided by 7 plus 3d. So on the side here, I'm going to go ahead and do so we need to, oh, this is a nasty fraction. If you can't tell, this is the first time I'm working through these problems, but we'll do that. We need to do 2 plus 16 divided by 7. Let's see, what would that be? That's going to be 14 plus 16 over 7, and that's going to equal 30 divided by 7. Okay, so then we'll get that 30 divided by 7 is going to equal 3d, or that d is going to equal 10 over 7, right? 30 divided by 3, so 10. Cool. Now, we're done. Almost. So now we go back. And this is where a lot of people kind of forget, well, I just did all this work. I just, I found the way that my particular solution should look. So, but don't forget that. All this work that we did is to find A, B, C, and D. And then if we go ahead and we take what we originally thought our particular solution to look like, we said that our particular solution looks like this. Well, now, since we did the method of undetermined coefficients, we, know our now determined coefficients. So A was nothing but -2. B was nothing but 6. And then it's going to be multiplied by T plus C, which was -4/7. And then D was 10/7. We just found X sub P. Great. Now the very last thing is your kind of aha moment. This worked. It looks good. We didn't run into any problems, which is nice. So we must know that our solution is going to equal X, our homogeneous solution, plus our particular solution. Well, so that means that X equals, what was our homogeneous? Our homogeneous was simply just this. Copy it and put it down here. I might need a little bit more room because I decided to write too big. Plus our particular solution. Well, that is simply just -2, 6 times t plus -4/7, 10/7. Boom. That is our answer. So I know that these take quite a bit of time. But yeah, I hope this helped, and please, this is my first video that I've made, so if you have any advice on what you would like me to kind of go over next, please go ahead and drop it in the comments. Thanks for listening, though.